Good morning, students. Today we are going to discuss about interfacing devices. Before going to discuss about interfacing devices, first we know about what is meant by interfacing. Interfacing is nothing but communicating multiple number of I/O devices to the processor is called interfacing. The device which is used for this purpose of interfacing is called interfacing devices. Like such a one type of interfacing device is 8255 programmable peripheral interfacing device. Why it is called as programmable peripheral interfacing device means this is the device used for interfacing multiple number of peripherals by means of programming done in the register which is present in the 8255, and that is why it is called a programmable device. This is the device which is containing totally three ports, which are port A, port B and port C. Each port contains 8 number of I/O pins, so that 3 ports of 8 I/O pins, which is totally 24 I/O pins. And these 24 I/O pins are used to connect different number of I/O devices, like 24 number of I/O devices totally to the processor. Next, it is block diagram of PPI, and in this block diagram of PPI, the main important blocks which are data bus buffer, read or write control logic, group A and group B. Data bus buffer, which is used for the purpose of transferring data, and is containing the number of data lines are 8. So it is a 8-bit bidirectional data bus. The number of data lines are D0 to D7. Read or write control logic is responsible for generating the read signal, write signal, A1, A0, reset and CS. CS refers chip select signal. What is group A and group B? Group A is a control of port A and port C upper. This is the group A is a combination of the port A lines as well as port C upper lines. Group B is having a control of port B I/O lines and port C lower I/O lines. Here we have only the three ports, port A, port B and port C, but the port C is again be splitted into two of the ports, like as port C lower and port C upper. Port C lower as PC0 to PC3, port C upper as PC4 to PC7. And the port A, which is an 8-bit buffered I/O latch, can be programmed by mode 0, mode 1 and mode 2. These are the different modes of operations that we will discuss later. And the next one is port B. Port B is also an 8-bit buffer I/O latch. It can be programmed by only the two modes of operations, mode 0 and mode 1. Also the port C is an 8-bit I/O latch. It is, as I already said, it is split into two parts, like port C upper and port C lower. And it can be programmed by one of the mode of the operation, which is bit set or reset mode of operation. That is also we will discuss in soon. This is showing the pin diagram of 8255 PPI. What are the main important pin functions of 8255 PPI is, one is the data bus D0 to D7, which is an 8-bit bidirectional bus used for transferring the data. Another one is CS bar. It is an active low signal. Active low means whenever this is the signal is in low, that it is considering it as active. That is the meaning of active low signal. Whenever it is low, it enable the chip. That is the meaning for CS, chip select. Another one is RD bar. This is for read operation. For enabling the read operation, we use this RD bar signal. WR bar, for enabling the write operation, we use this signal. And the next one is address pins, A0 and A1 pins. These two A0 and A1 pins are used for select the ports that we require. If A0 and A1 is 00, we may select port A. Like if A0 and A1 is 01, we select port B, like port C. Also, we may select the control register. What is this control register? This is a control register used in 8255 PPI for programming done in the 8255 PPI operation. The programming here is nothing but how we could select the mode of operation, how the devices are chosen to be as the input device or output device. Like such a programming is done in the register is called control register. The format that we stored in this control register can only decide what the programming which is given in the PPI operation. That is the meaning for control register. The reset signal. Reset signal which is used to reset the device, and as usually it is used for clearing the registers. PA0 to PA7, PB0 to PB7, PC0 to PC7, all these pins are the different 3 ports IO pins, port A, port B, port C simultaneously. And the next one is, as I already said, port C is divided into 2 of the sub ports. One is the port C lower, another one is port C upper. PC0 to PC3 is port C lower, PC4 to PC7 is port C upper. And these two groups working in separately using 4 data lines. The next one is data bus buffer. As I already mentioned about this one, data bus buffer is for transferring the required data. It transfers only 8 bit of data through the lines of D0 to D7. The next one is read or write control logic, and it is responsible for transferring or generating the read signal, write signal. A0 lines means A0, A1 is responsible for selecting the ports. CS is for enabling the chip. Likewise, this is a block which is used for generating read or write operation signals. And the next thing which is about what are the different modes of operations which are there for the 8255 PPI. In the operation modes of 8255, there are mainly two different modes of operations. The one which is bit set or reset mode of operation. Another one which is IO mode of operation. What is called bit set or reset mode of operation? Bit set or reset. The name itself indicates that this is a mode of operation which made the bit either to set or reset. But this is the mode of operation is using only the one port, and that port which is port C. So meaning that the port C bits can be set or reset by means of this mode of operation. Whenever in our PPI operation it is required to use only the single port, we choose or we prefer this is the type of mode operation. For that purpose we use this mode, bit set or reset mode of operation. Another one which is IO mode of operation. IO modes, here name itself indicates this is a mode of operation for especially the ports are to be used for the purpose of IO devices connection. That is why the mode is called as IO mode of operation. And this is the IO mode of operation is again be divided into 3 sub modes. The one which is mode 0, mode 1 and one is mode 2. Mode 0, which is called simple input or output, meaning that in this mode we use the port 3, port A, port B and port C, all the 3 ports that we make in use, and these 3 ports are to be used as individually. And these 3 ports can be used for the purpose of IO devices connections. Here, the one drawback in this mode 0 operation is we don't use any type of handshaking signals. That is the drawback of mode 0. For this, to avoid such a drawback, we may choose another one which is mode 1. And this is the mode 1 which is having an advantage that it is input or output with handshake, meaning that it is providing a connection of input or output devices along with handshaking signals also. So that is the advantage behind the mode 1. To avoid or to lead the drawback of mode 0, we may use the mode 1 operation. In this mode, input or output is transferred by means of handshaking signals. What are the handshaking signals? Before to know about the handshaking signals, let us know about what is meant by handshaking signals. Handshaking signals are nothing but the signals which provide an assurance where the communication is effectively done. That is the signals which is called as handshaking signals. Suppose here the handshaking signals are given like as STB, strobe signal, ACK, acknowledgement signal, and the one more is busy signal. So whenever the effective communication is required to be provided in between the two devices, we may use these type of handshake signals, because suppose see in this diagram, here the computer device is an electronic device, whereas the printer device is a mechanical device. And this is the computer device which is considering it as some sort of a faster device, where the printer device is considering it as some sort of slower device, right? So whenever the printer is ready to accept the information by the computer, then only, yeah, the computer is required to send the information. So when the printer is ready to accept the information, then only your computer can start its sending of information. That readiness by the printer is going to be considered by using of the signals are called handshaking signals. So for that purpose we use the handshaking signals. This is the strobe signal sent by the computer to know about the readiness of printer, and whenever the printer is ready for accepting the information, it is also sending another one more signal which is acknowledgement. If printer is not ready to accept the information, then it send the one more signal which is busy signal. With this information, computer can know the readiness of printer, whether it is required to transfer the information or not. That is about the mode 1 operation. And the same example I just given here. And the one more which is mode 2. Mode 2 operation is having an advantage of bidirectional IO data transfer. So in this mode 2 operation, the one thing which is required to remember is we use only port A here, meaning that here we use only group A. The group A, as I already said, group A consisting of port A and port C upper. So here the port A and port C, suppose mode 1 that we are using, in that mode 1, port A is to be used for connecting the IO devices. Port C upper is used for the helping of handshaking signals for the port A. As well as if we use the port B in mode 1 operation, port B is going to be used as for the IO devices connection, and port C lower is to be used for the handshaking signals provision. Like here, mode 2, it is only the possibility to use group A. That is, port A is going to be used as a bidirectional, as well as port C is going to be used for the handshaking process. In this mode 2 operation, we don't use port B or port C lower, meaning that we are not using group A control signals in the mode 2 operation. That is the meaning port A, port B, port C, where that we are using. In mode 0 operation, that we are using port A, port B and port C. In mode 1 operation, we are using port A as well as port B. For port A, port C upper is for handshaking signals. For port B, port C lower is used for handshaking signals in the mode 1 operation. Whereas in mode 2 operation, we use only the group A, that is consisting of port A, and port C upper is using as for the handshaking signals. This is about the mode 1, mode 0, mode 1 and mode 2 operations. And the next one is, what is the control word format? As I already indicated, the control word register, and this is the control word register is playing a very important role how the programming is done for the 8255 PPI operation. Let us see what is this control word format. As I already indicated that the modes of operations for 8255 is mainly two types. One which is bit set or reset, and the one is IO mode. Coming for the bit set or reset mode of operation, the control word format is like this. See the control word format here. The control word format is totally of 8 bits. D7 bit is going to be used to represent whether the type of PPI operation is using bit set or reset mode of operation or not. If the PPI is using the bit set or reset mode of operation, then that D7 bit is 0. If suppose that D7 bit is 1, meaning that PPI is not using bit set or reset mode. So D7 bit indicates whether your PPI is operating in bit set or reset mode of operation, or your PPI is operating in the IO mode of operation. If D7 bit is 0, it is meaning that it is operating in the bit set or reset. If D7 bit is 1, meaning that it is operating in the IO mode of operation. Like D6, D5 and D4 are the bits which are called as we don't consider those bits, meaning that D3, D2, D1 is used to address the port bits of, as I already indicated that the bit set or reset mode is going to be used only for the one port, that is port C. So in that port C, it is containing totally 8 bits, 8 IO bits. That 8 IO bits is going to be selected as by means of these addressing bits of D3, D2 and D1. Suppose D3, D2, D1 is 0000. It is meaning that it is selecting PC0. If it is 0001, meaning that it is selecting PC1. Likewise, for that bit selection purpose, we use this D3, D2 and D1 bits. In D0 bit, D0 bit is used for indicating whatever the bit that we selected, whether what that selected bit is need to make, whether we need to make that bit is a set or reset. For that purpose, we use D0. Suppose we selected one of the bit is PC4, that D0 bit will indicate that how to make that PC4 bit is. If that D0 bit is 0, meaning that PC4 bit is 0. That D0 bit is 1, we are changing that PC4 bit as 1. So likewise, this is the control word format that which is given in the mode of operation, bit set or reset mode of operation. We also have another mode of operation which it is called as IO mode of operation. And in this IO mode of operation, the control word format will be like this. How like the control word format? Let us see. And as I already indicated, D7 bit is to be used for the purpose of indication of mode of operation, whether the PPI is operating in the bit set or reset mode of operation, or the PPI which is used for the purpose of IO mode of operation. If D7 bit is 0, meaning that PPI is operating in the bit set or reset mode of operation. If D7 bit is 1, indicating that the PPI is operating in the IO mode of operation. So D7 bit is indicating which mode of operation that we selected in the PPI operation. Coming to the D6 and D5 bits. D6 and D5 bits are to be used for the purpose of mode selection. As I already said, IO mode is again be divided into 3 of the sub modes: mode 0, mode 1 and mode 2. Mode 0 is called as simple IO. Mode 1 is called as input and output with handshake signals. Mode 2 is called as input or output bidirectional transfer. And these mode selection is so possible by using the bits which are D6 bit and the one is D5 bit. If D6 and D5 is 00, we select the mode which is mode 0. If D6 and D5 is 01, we select the mode is mode 1. If D6 and D5 is 1 or anything of the D5, means whether it may be a 0 or 1, we may select the mode is mode 2. Like that, D6 and D5 is to be used for selecting of modes. Next, D4 bit. D4 bit is to be used for the purpose of selecting the port B. How like we select the port B? Whether we are selecting the port B is a input port or output port. If D4 bit is 1, we are considering that the port B is input port. If the D4 bit is 0, we are considering the port B is output port. What about the D3? Just like as D4, D3 is indicating about the port C upper. As I already mentioned, port C is divided into two of the subports, port C upper and port C lower. Here the D3 bit is indicating only about the port C upper. Port C upper means PC4 to PC7. If D3 bit is 0, mentioning that port C upper is output. If D3 bit is 1, mentioning that port C upper is input. Next one is D2. D2 is to be used for the purpose of mode selection again, and if it is 0, it is for mode 0. If it is 1, it is for mode 1. As I already indicated that group B is not at all using in mode 2 operation. That's why here in the mode selection we prefer only the two changes. For 0, mode 0. For 1, mode 1. So there is no option for group B. There is no option for group B in mode 2 operation. That is why we choose only the two selections here for the mode. One is 0 for mode 0, 1 for mode 1. That is about the D2 bit. Next, D1 bit. What is the D1 bit? D1 bit, which indicating that port B, for the selection of port B, whether port B is input port. If that bit is 1, it is input port. If that bit is 0, that is output port. Like D0 bit. D0 bit is indicating port C lower. See here, D3 bit is indicating port C upper. D0 bit is indicating port C lower. Port C lower. If you want to make this port C lower is input, make this one is 1. If you want to make the port C lower is output, make that bit is 0. And this is the control word format that which is given for the mode of operation is IO mode of operation. Whatever the format that which it is provided in the IO mode of operation, or whatever the format which is provided in the control register, as per the format only the programming will be done in the PPI operation. That is why the device here, which it is called as programmable peripheral interfacing device. Why we choose this programmable peripheral interfacing device for the interfacing of 8086 means with this PPI device it is so possible to connect totally 24 number of IO devices at a time to the 8086. So it is possible to interface 24 number of multiple IO devices at a time to the 8086 processor. That's the thing why we choose this type of PPI device. This is about the PPI device, and students, in the next coming class we will discuss about the DMA controller.